Okay. Where are we? Handling pawn deaths. Exciting stuff. Exciting stuff.
Okay, so our goal for this video is to implement death for our pawns. So if I get hit a couple of times
Death
from
to
our tower, you'll
pawns!
see that I have disappeared because my tank has died. And if I'm skilled enough, if I can go ahead and destroy one of them, you'll see that it disappears as well. So we're going to implement death for these pawns in this video. Hello and welcome back. Now we're already applying damage to the pawns when they're being hit by projectiles. We now need to figure out how we're going to handle actor death. This means we're going to need some sort of function to handle the destruction of a particular actor. So we're going to create a handle destruction function. We also need an actor died function, which can allow the game mode to handle what happens when an actor in our world dies. And we're going to call this actor died function when the health value reaches 0 for a particular pawn. So let's talk about a bit of a roadmap for how we're going to implement this system. We know that we have a projectile and it's calling applied damage, and this results in the damage taken function
Oh,
responding to
Lily
that
Luna.
target broadcast
I
in the
gotta
health
follow you
component.
back.
So we need to figure out what to do from there. Well, our game mode can have a function
Ow,
to
don't bite
handle
me,
when an
Kona.
actor dies. So in damage taken, we can check to see if the health reaches 0, and at that point we can call the actor died function on the game mode. And from there, our pawn can handle its destruction. So ultimately, it'll be up to the game mode to call the handle destruction function on the actor that died. So we have a bit of a game plan. So let's outline the steps to take to implement this. First, we're going to create the handle destruction function, and we're going to place this on the base pawn class to handle functionality that should happen when any of our pawns die. And we'll also implement this in the tank and the tower classes, since they'll each have their own unique functionality when they die. Then we'll create an actor died function and place this on the game mode class, so that we can call handle destruction from there. After that, we'll call handle destruction in the actor died function on the game mode, and then we can call actor died from the health component when the health reaches 0. So let's start with our first step, creating the handle destruction function. So I'm here in base pawn.h, and I'd like to add this handle destruction function. Now, I'm planning on calling this from the game mode, which means it's going to need to be a public function. So I can place this function here in the public section. It's going to be void.
This in base pawn. Void.
And I'm going to call it handle destruction. Now, it doesn't need to take any input parameters. It's simply going to handle the destruction of this particular pawn. So let's implement this function in the base pawn.cpp file, and I'm going to place it right here under the constructor. So I have handle destruction, and I'm going to place the a base pawn class name just before the function name here. Now this is going to be things that happen when any of the pawns based on base pawn dies. So I'm going to place a to-do here that says what we're going to do in the handle destruction function. I'd like to handle all the visual and sound effects here that have to do with the pawn dying. So I'm just going to say visual/sound effects, and we'll leave it at that, and we'll make sure to remember to implement this when we get to the special effects and sounds part of this section of the course. Now we have handle destruction here, but I'd like to also put a handle destruction function in both the tank and tower classes to handle what happens when those pawns die. And the most simple implementation of destruction is perhaps going to be for our tower. So let's go into tower.h, and we'll add a public function here called handle destruction. So I'm going to say void handle destruction, and I'm going to implement this in tower.cpp just under. And I'm going to implement this in tower.cpp just under the tick function. So here's tick, here's handle destruction, and I'm going to prefix the function name with a tower just like that. Now in the handle destruction function for the tower, I'd like to call the super version so that handle destruction in base pawn gets called, and we'll get those visual and sound effects when a tower dies. So I'm going to say super handle destruction just to make sure that that gets called. And after that, I'm simply going to destroy the tower. Now we've seen how this works. We simply call the destroy function, and that's going to handle destruction for the tower. So I can save this and close out of the tower.h and cpp files. And now I can place a handle destruction function in the tank class. So I'm going to go to tank.h and declare a public function here under the tick function called handle destruction. And I'm going to go to.
Why is that underlined? Ah. This should be fine.
Tank.cpp and implement this just under tick here, not forgetting to prefix the function name with a tank. Now, just like in the tower class, we'd like to call super handle destruction. And that way, we'll get those visual and sound effects. Now for the tank, we're going to do something a little different. I'd like to hide the tank rather than destroy it, and then we can disable its tick functionality, so it'll still exist in the world and we'll still be possessing it, so we still get that view from the camera, only we won't be able to see it or move it around. So to hide the tank, we can call a function called setActorHidden in game. And this will take a boolean, and if we pass in true, then we will effectively hide the tank. Now I'd also like to disable ticking, and there's a function for that as well. It's called setActorTickEnabled. And for this, I'm going to pass in false, which will disable ticking for the tank. So that takes care of our handle destruction function. So we have our handle destruction function. Our next step is to create an actor died function in the game mode. So let's implement that. So I'm here in ToonTank's game mode.h, and here I can create the actor died function. Now I plan on calling actor died from the health component class, which means this also needs to be a public function. So I'm going to add a public section and create the actor died function. Now this will be void, and I'm going to call it actor died, and this can simply take an actor pointer called dead actor. And now we can implement actor died in ToonTank's gamemode.cpp. So I'm going to place it here and prefix the name with ToonTank's game mode, and now we have an actor died function. Now I'd like to check to see if the dead actor is the tank, which means I'm going to need a variable for the tank. So back in ToonTank's game mode, I'm going to make a private section. And I'm going to add a tank variable, which I'm going to forward declare, and it's of type a tank pointer, and I'm simply going to call this tank. And I'm going to need to initialize this with the address of the tank pawn, and I can do that in begin play. Now we've seen that begin play is a protected function, and we're going to keep it protected here in the game mode, so we can override begin play. So I'm going to say virtual void begin play override, and I can implement it here in ToonTank's gamemode.cpp.
Virtual void begin play override.
Override, and I can implement it here in ToonTank's gamemode.cpp. So it's going to be void begin play, and I'm going to use the ToonTank's game mode class name, and the first thing I'm going to do is call super begin play. That way we get parent functionality, and I can get the player pawn using gameplay statics. So I'm going to first include gameplay statics, and that's in kismet/gameplaystatics.h as we've already seen. And here I can take tank and assign it the value of gameplay statics get player pawn. Now this takes a world context object, which we can use this for, and I'm going to use 0 as the player index, since our tank will always be player 0. Now we know that getPlayerPawn returns an A-pawn pointer, and tank is of type A-tank, a child class. And we've seen that we need to cast to that A-tank class if we'd like to store this result in an A-tank pointer. So first I'm going to include the tank header. So I'm going to say include tank.h, and then I'm going to cast to a tank. So I'm going to say cast to a tank, and I'm casting the value returned from getPlayerPawn, so I'm going to place that in the parentheses here. And now we'll have a pointer to the player pawn in the form of an A tank pointer. So now that we have the tank, we can check to see if our dead actor is the tank. So we can say if dead actor double equals tank. Now, tank may be null, and that's okay because if tank is null and dead actor refers to the tank itself, then this will fail the if check, and we won't actually attempt to access a null pointer because we won't make it to the inside of this. Now, if the dead actor is in fact the tank, then I'd like to call the tank handle destruction function. So we're going to call tank handle destruction. Now, after I call the handle destruction function, I'd also like to disable input for the tank pawn. So I can get the tank and call the built-in function that tank inherits called disable input. Now, disable input requires an A player controller. Now, we know that the tank class, if we come here into tank.h, has this player controller ref variable, which is a pointer to A player controller, which is why I'm starting to think that ref is a very awful name for this variable since it's not a reference, it's a pointer. I'd almost rather call it tank player controller. So in fact, why don't we go ahead and rename this? This is something that developers often do when they realize that they've given a variable a bad name. So VS Code has a way to do this easily. I can highlight this variable and hit the F2 key, and it's asking for me to rename it. I'm going to call this tank player controller. Now check this out. It's called tank player controller here. If I go to tank.cpp, I'll see that it's renamed here as well. So I didn't have to go in and look for it and find every instance of player controller ref. I can search for tank player controller and see that it's changed everywhere that it's used here. So that's a nice refactoring skill to have. So anyway, back here in ToonTank's game mode, I need to disable the input for the tank, and this requires a player controller. So I'm first going to check to make sure the tank player controller is valid by saying if tank, and I need to access that player controller. But recall that in tank.h, our player controller variable is private. Now we could expose this and make it public, or we could make a public getter function for this variable. I'd rather make a public getter as that's better programming practice. So up here in the public section, I'm going to create a public getter for tank player controller. Now it's going to return an A player controller pointer, and this function is going to be called get tank player controller. Getters are typically the name of the variable with get in the front, and they're also typically made const, as this function is not designed to change anything in this class. It's only going to return the player controller. So we're going to say return tank player controller, and that's all it's going to do. So now that we have a public getter function for the tank player controller, we can, so now that we have a public getter function for the tank player controller, we can access the player controller here from within the game mode. So we're going to say if tank get tank player controller and make that function call here. And if we reach the inside of this if statement, then the player controller is valid. So we can move this call to tank disable input right here, and we're going to pass into disable input the tank player controller. So we'll call tank get player controller here as well. Now, while we're accessing the player controller, I'd also like to take the player controller's b show mouse cursor boolean member variable and set this to false. So we're disabling input, and we're also making sure that the mouse cursor is not shown. So that takes care of handling the functionality for when the tank dies. Now, in the case that the dead actor is not the tank, I'd then like to check to see if it's an instance of the tower class. So I'm going to add an else if here. So what's going to be the conditional for this else if here? Well, I'd like to see if dead actor can be cast to an A tower, which means I'm going to need to include the tower class. So include tower.h, and then I'm going to attempt to cast. So I'm going to say cast, which takes angle brackets and parentheses, and what we're casting to is a tower, and what we're casting is dead actor. We'll attempt to cast dead actor. Now we can actually take the result of this cast and assign it and create a local variable here in the conditional. We can say a tower pointer, and we can call this destroyed tower, and assign it the value returned from this cast. And if we do that, then we have access to this destroyed actor, which is our dead actor cast to a tower. Now if this is successful, then we'll make it to the inside of the else if, and then we can take our destroyed tower, and we can simply call handle destruction. So now we have an actor died function here in the game mode, which calls handle destruction and also handles some more death-related functionality for the tank. So that takes care of step 2, creating an actor died function, and while we were at it, we also called handle destruction in the actor died function. So our last step is to call actor died when health reaches 0. Now, in order to call this function that exists on the game mode, our health component is going to need a variable that stores the address of the game mode. So let's go into our health component class. Here's health component.h, and I'm going to add a private variable here just at the bottom, and this will be of type a tune tanks game mode pointer, and we'll call this tune tanks game mode. Now I'm going to forward declare this so I don't have to include its header file here, and then we need to access the game mode. So let's go to healthcomponent.cpp, and if I scroll up, I see the begin play function here, and that is the perfect place to get a hold of the game mode. Again, putting it in the constructor is too early. We need to make sure that the game mode has been constructed and exists before we try to access it. Now here is a handy function on gameplay statics called getGameMode, and it says returns the current game mode base or null if it can't be retrieved, such as on the client. Now, on the client has to do with multiplayer programming, and we don't have to worry about that. We are running on the one and only machine for our game. So let's scroll down and we'll see that a game mode base takes a world context object. This is just an object in the world, and we've seen how to handle world context objects. So this exists in gameplay statics.h, so let's get that include. And here in healthcomponent.cpp, we'll paste our include for gameplay statics, and then we'll call getGameMode here. In begin play. So we're going to say tune tanks game mode and set that to the value of gameplay statics get game mode, and for the world context object I'm going to pass in this, and now we have the game mode. But of course get game mode returns a game mode base, and we're attempting to store it in the child class a tune tanks game mode, which means we're going to need to cast. That's right. So we need to say cast to a tune tanks game mode, and we're casting the result from get game mode, so I'm going to place that in the parentheses there. And we're using tune tanks game mode, so I'm going to include that header file at the top. So I'm going to say include tune tanks game mode.h. So we have the game mode here in the health component. We're ready to go down here into damage taken and check to see if our health reaches 0. And in that case, we can use our tune tanks game mode pointer to call the function actor died, passing in the actor that died. And this is going to be your challenge. So in the health component class, in damage taken, you're going to check to see if the value of health has reached 0 or gone below 0. If that's the case, then call actor died using the game mode, since we have a pointer to the game mode. Don't forget to check to see if this pointer is not null first. And once you call actor died, you're going to need to pass in an actor. You're going to pass in the actor that died. So pause the video and implement this in the damage taken function now.
On the game mode.
Okay, so we've already subtracted damage from health. We're now ready to check to see if that health value has reached 0. So I'm going to say if health is less than or equal to 0.f. And if that's the case, then it's appropriate to call actor died. Now, because we need to check to see if the game mode is valid, I can place an and here in this if check and check to see if tune tanks game mode is valid. If it's null, then it will return false here, and we won't reach the inside of the if statement. So if we reach the inside of the if statement, tune tanks game mode is valid, and health has reached 0. So we can say tune tanks game mode and we can call actor died. And this takes an actor, and we know that the actor that died is going to be the damaged actor. So we're going to pass in damaged actor, and now we can compile this. And look at that, we have a success.
Compile, compile, compile.
Successful compile, so let's hop back into the editor.
Uh-oh. Int a base pawn handle. Annoying. Annoying. Okay. Base pawn. Oh, duh. No! CPP. I'm not gonna see this. Game mode CPP. Line 30. Layer. I think that should do it. Fingers crossed. Success?
And here in the editor, why don't we go ahead and test out def. Let's see if I can destroy some of these tanks before becoming destroyed myself. That's going to be kind of a challenge. Oh, there's one. I killed one of them, and I got the second one. Oh, and I died. So you can see that this game is a lot more fun now that we've added death and destruction to our pawns.
Oh, I died.
This is great. Okay, so what I want you to do is give yourself a huge pat on the back because in this video, we handled actor death, which involved quite a bit of interaction between these classes in our game. Now, the way death is implemented is that the pawn simply disappears, which means we still need a few things.
All right, but I don't have health on my towers. Forgot to do that.
We need win-lose conditions. We need a way to show the player that they've won or lost. If we reach the inside of the if statement, and I got the second one. Oh, and I died. So, and this takes an actor, and we know that the actor that died is going to be the damaged actor. So we're going to pass in damaged actor, and now we can compile this. And look at that, we have a successful compile, so let's hop back into the editor. And here in the editor, why don't we go ahead and test out death. Let's see if I can destroy some of these tanks before becoming destroyed myself. That's going to be kind of a challenge. Oh, there's one. I killed one of them, and I got the second one. Oh, and I died. So you can see that this game is...
Okay. That should work. All right, let's go to this guy. New tank. Where's health? Oh, you know what? It's gonna be, there it is. Aha. Boom. Hey! Killed one. Got the bitch. Destroy that. Yo, I'm better. Okay.
is a lot more fun now that we've added death and destruction to our pawn. So this is great. Okay, so what I want you to do is give yourself a huge pat on the back because in this video, we handled are going to come very, very soon. So Hello and welcome back. Now, we've already created the ability to handle death for the tank and tower, and we saw that this involved some extra steps with our tank since we accessed the player controller to disable input and disable showing the mouse cursor. Now, we'd like to have our own custom player controller class so that we can add functionality to it that will handle this for us, and then we'd like to create a blueprint based on this class so that we can access some of the exposed variables on the player controller, such as which mouse cursor to show once we actually start showing the mouse cursor. So we're going to create a player controller class and add enabling and disabling input functionality, and then we're going to create a blueprint and set the mouse cursor type in blueprints. Now, creating this class is something you know how to do. So you're going to create a player controller class for your challenge. Create a new C++ class and choose player controller as the parent class. Call this ToonTank's player controller or something appropriate like that. And once you're done, create a blueprint based on this class. Now, once you have the blueprint, you can assign this as the default player controller in the game mode blueprint. Do this in the game mode blueprint itself. Pause the video and create the player controller class for the tank now.
You're a toon tank. Okay. Oops. I don't know what I just clicked. Oopsie doozle. Okay. There we go. We're going to call this.
Okay,
I
so I'm
did
back in
it.
the editor. I'm going to right-click, click New C++ class, and scroll down, and I'll see that Player Controller is an option here. So I'm going to select Player Controller and name my new Player Controller Toon Tanks Player Controller, and click Create Class. And here I have my new Player Controller class. Now the next step is to create a blueprint based on this. So I'm back in the editor, and I didn't tell you to do this, but I'm going to create a new folder here in my Blueprints folder called Player Controller. And if you'd like the same folder structure, you can create this folder now if you haven't already done so, and then move your player controller blueprint into this. If you don't know how to move a blueprint from one folder to another, it's quite simple. You go to the folder that contains the blueprint, click and drag into the correct folder, and click Move Here. Now, I don't want to move my projectile to this folder, so I'm just going to click here in the content browser to cancel that action. So now I have a player controller folder. I'm going to right-click and click Blueprint Class, and in the search, I'm going to look for Toon Tanks Player Controller and select that class and click Select. Now I can call this BP underscore Toon Tanks Player Controller. So I now have a player controller. Now I need to set this as the default player controller. So I'm going to go to the Game Mode folder, open BP Toon Tanks Game Mode, and open the full Blueprint editor, and here I see Player Controller Class. I'm going to click the dropdown and select BP Toon Tanks Player Controller, and compile and save, and close out of that. So now we have the custom player controller class. We're ready to add some functionality to this. So what I'd like is a function here that can set the player enabled state, whether or not the player is enabled to add input that will move the tank. Now I plan on calling this from the game mode when the actor dies, so I'm going to make a public section here, and the function is going to be void, and I'm simply going to call this set player enabled state, which can take a boolean called be player enabled. This way, if we call this function, we can either pass in true if we'd like the player to be enabled, or false if we'd like it to be disabled. So let's implement this function in toontanks playercontroller.cpp. So here's my function, and of course I need the class name here, so it's going to be a toontanks player controller.
Why is this squiggly?
and there's the scope resolution operator. Now this function is going to be quite simple. It's going to check the value of B player enabled, and we can do that with a simple if check. So I'm going to say if B player enabled, and I'd like to access the pawn and enable or disable input. And the way to access the pawn that this player controller is possessing is to use the function get pawn. This returns an A pawn, and the pawn class has the function enable input, and enable input, as we've seen, requires a player controller, so we can pass in this. Now I'm getting the red squiggles because we need to include that pawn class type. And we can easily see the include for the pawn by either going to the Unreal Engine documentation for a pawn, or we could simply go to our base pawn class, which inherits from a pawn. And because it inherits from a pawn, we've seen that it needs to include the pawn header there, so I can copy that include. It's gameframework/pawn.h. So back in Toontank's player controller, I can paste that include here at the top to get rid of those red squiggles. So this takes care of the case when B player enabled is true, but we also need an else case here. In the else case, we're going to call get pawn, and there's a function just like enable input that is designed to disable input, and it's called, as you might guess, disable input. And this also requires a player controller, for which we will pass in this. Now the player controller has that B show mouse cursor, and we're going to set that as well, and we'd like to set it based on whether or not the player should be enabled. So whatever the Boolean value of B player enabled, we're going to set B show mouse cursor to that value. So we're going to say B show mouse cursor equals B player enabled. Now, we haven't shown the mouse cursor yet. We're going to get to that part. We'd actually like to see the mouse cursor while we're playing the game so we know where our tank is aiming. So we'll get to that soon, but for now we have this nice function in the player controller, and we'd like to call this function from the game mode. Now to show you what I mean, I'm going back to game mode, and here's the actor died function, and you'll see that we're disabling input, and we're setting B show mouse cursor here. So the reason I'd like to have a function on the player controller is so that we can simply call that function, passing in a Boolean value. In this case, we'd pass in false, so that we'd get that disable input function called, and B show mouse cursor would be set to false. So we can simply call that function here. Now, rather than calling tank get player controller, which returns a player controller, I'd like to have a pointer variable that allows us to access that player controller. So here in Toontank's gamemode.h, I'm going to add a private variable. I'm going to forward declare it, and it's going to be of type A Toontank's player controller. That's a pointer, and I'm going to call this Toontank's player controller. And I can set this here in Toontank's game mode in begin play using gameplay statics. Here in Toontank's game mode in begin play using gameplay statics. Now, if you were wondering if gameplay statics had a get player controller function, you were right. This is one of those handy static functions that requires a world context object and a player index. So we can go ahead and copy the include for gameplay statics and call this here in begin play. So I see at the top here I already have gameplay statics. That's because we're using it already here in begin play to call get player pawn. We're going to do the same thing here to set the player controller pointer. Now this is something you should know how to do, so why don't you pause the video and do a little mini challenge here and just set the value of Toontank's player controller.
We're going with the
Okay, so we're going to say Toontank's player controller, and we're setting it equal to the result of u gameplay statics get player controller. And we know the world context object can be this, and the player index is not 9, but 0. And of course, we know that this returns a player controller and not a Toontank's player controller. So just like we did with tank here, we're going to cast. So I'm going to say cast to a Toontank's player controller, and we're casting the result of get player controller. So now after begin play, we will have the Toontank's player controller. And now we can come up here, and instead of getting the player controller using get player controller directly from the tank, we can check to make sure our variable Toontank's player controller is valid, and then we can call that function we made. Let's go back and look at it. Is valid, and then we can call that function we made. Let's go back and look at it. It's called setPlayerEnabledState. And here in the game mode, we'd like to disable input and stop showing the cursor, which means we're going to pass in false for this. So we're going to say Toontank's player controller setPlayerEnabledState, and we're passing in false for this. And we're using Toontank's player controller, which means we need to include Toontank's player controller. So here at the top, we're going to include Toontank's player controller.h, and now we have this type defined. Okay, let's go ahead and compile this. And the last thing we'll do before we wrap this up is go into our player controller blue.
Toon Tanks player controller. Will this compile? Will this compile? Huh? Huh? I haven't touched these. Ah! CPP 31. Toon Tanks player controller. Should have declared a Toon Tanks controller. Spelled it wrong. Compile. Fifteen, 17. Please compile.
Blueprint, and I'd like you to scroll down to the mouse interface section, and you'll see that it says default mouse cursor. Now we can
There we go.
click the drop down, and there are a number of different cursors to choose from, and I'm going to choose crosshairs. Now, we're not showing the mouse cursor yet, but once we start the game, we're going to show the cursor, and when we do, I like it to be crosshairs instead of the default white arrow that we always see when we look at the mouse cursor. So set default mouse cursor to crosshairs, and we'll be able to see those crosshairs once we actually enable the mouse cursor. So in summary, we created a custom player controller class, and we're using that to enable or disable input with a function that we placed on that class, and we're also using that function to show the mouse cursor or hide the mouse cursor based on the boolean passed in, and in the blueprint that we created, we set the mouse cursor type, and we're going to see very soon what that crosshairs mouse cursor looks like when we start showing the mouse cursor when the game starts. So great job. We now
Can I sneak another one in? I can. I can totally do it.
Now we have a game mode, and we'd like to use the game mode to determine when we can start the game. Now, some games have a delay or a countdown timer that starts when the game starts, and after a set amount of time, then the player is allowed to move the character, or in our case, the tank, around in the world. So we're going to implement that in this video. This is going to involve first disabling the input so we can't move around when the game first starts, and then we're going to set a timer, and after a set amount of time, then we can enable input. So let's go back to Toon Tanks game mode.h and add a couple of things here. First, I'd like to add a float for the amount of time that should pass when the game starts before we can start moving. So this float is going to be called start delay. And I'm going to initialize this to 3.f so that we have to wait 3 seconds before we can start the game. Now, as soon as the game starts, I'd like to start this timer, which means I'd like a function that will start this timer, and I'm going to make this a private function as well. I'm going to make this a void function called handle game start. Now, I can implement handle game start in Toon Tanks game mode.cpp down here under begin play. Now, I won't forget to add the Toon Tanks game mode class name here. And now I have a handle game start function.
Thanks, game mode.
Now, the place to call this would be begin play, since begin play is called at the start of the game. So I'm going to call handle game start here in begin play. And since we're doing a couple of things here at the beginning of the game, where setting the tank and the Toontank's player controller variables, I'd like to move these into handle game start. So I'm going to move those right down into handle game start. And that way, tank and Toontank's player controller will be set since we're calling handle game start here in begin play. So here is where I would like to start a countdown timer, after which we can enable user input. Now, before we start the timer, I'm going to disable input so we can't move the tank just yet. And that's going to require our function we placed here in Toontank's player controller called setPlayerEnabledState. And that means I'm going to use Toontank's player controller. And if I'm going to use Toontank's player controller, it's a good idea to make sure it's valid. So I'm going to say if Toontank's player controller, and if we reach the inside of this if statement, then I can take Toontank's player controller and call setPlayerEnabledState and pass in false. And that way, our tank will not be able to move. And I see the red squiggles, and that's because I said tank's player controller rather than Toontank's. So spelling it correctly, now I get no errors there. So next, we need to start a timer. Now we know that timers involve using an ftimer handle, and we can actually create an ftimer handle rather than having a member variable that belongs to the class. So I'm going to go ahead and do that, and I'm going to call this playerEnableTimerHandle. And next, we need to set a timer. Now, for the callback function for our timer, I'd like to use setPlayerEnabledState, but setPlayerEnabledState is a function that requires an input of type Boolean. Now, we haven't seen how to set a timer using a callback that requires input parameters. This is going to involve a new concept called a timer delegate. So let's take a look at Unreal Engine's timer system again. We know that there's a World Timer Manager, which manages our timers, and it has a setTimer function. Now, there are multiple overloads of the setTimer function. We've seen one of them already. Now I'm going to talk about another version of this function, and this version requires a timer handle, a timer rate, or a delay time during which we must wait before our callback function gets called, and instead of taking the address of a callback function directly, it can take something called a timer delegate. This is a struct of type ftimerDelegate, which allows us to create an object that can bind a function directly to it, and timer delegates can bind functions that require input parameters. Now we can create an ftimerDelegate variable and initialize it using the createUObject function from ftimerDelegate. This will create a new timer delegate and initialize it based on what we pass into the parentheses. This will take a user object, which is of course the class that our callback function exists on, and next it takes the address of the callback function itself, followed by any input values that we would like passed into our callback once it gets called. From there, we can call setTimer from the World Timer Manager and use the overload that takes a timer delegate. This overload requires the timer handle itself, the timer delegate, the play rate or a float that determines the delay before which our callback will be called, and then a Boolean to determine whether or not our timer should loop. So we know how to create an ftimer delegate. So I'd like you to create one in the handleGameStart function inside of our new if statement. So create a local ftimer delegate and use ftimerDelegate createUObject. Now we're going to need to pass in a user object, and usually we've been using this as the user object, but the function we'd like called exists on the player controller. So pass in our variable Toontank's player controller as the first input. That's going to be the user object. And the callback function is going to be setPlayerEnabledState, that function we added to our custom player controller.
I don't have a handle game start. Is that what I was just working on? Oh yeah, it is. Duh, just created it.
Don't forget the address of operator. And as the third input, we're going to pass in the value true. This is what will be passed into setPlayerEnabledState when our callback gets called at the end of the timer. So pause the video and give this a try now.
Already did it.
So just under our timer handle, I'm going to create a local ftimer delegate. And I'm going to call this playerEnableTimerDelegate. That's okay if you named it something else. Now I'm going to initialize this using ftimerDelegate createUObject. And this will first take a user object, and that's going to be our Toontank's player controller. So I'm going to say Toontank's player controller as the first input, and for the second, we need our callback function. And that's going to be a Toontank's player controller setPlayerEnabled. state, and I can't forget I need the address of operator for this function address. And the value that I'd like passed into this callback function is going to be true. That way, at the end of the delay time, when this callback gets called, true will be the value passed in to the callback function. Now I'm ready to call set timer, which means I need to call get world timer manager, and then from there I can call set timer, and the function overload we're using first takes a timer handle, and that's going to be player enable timer handle. The next input I'm going to pass in will be the delegate, so that's going to be player enable timer delegate. Next we need our delay time, and that's going to be start delay, which is the float we just created. So next I'm passing in start delay, and finally I don't want this timer to loop, so I'm going to pass in false so that we don't get looping behavior. Now I'm going to go ahead and indent these inputs so it looks pretty, and now we're calling set timer using our new timer delegate. And at the end of this delay time, we should get our callback function setPlayerEnabledState called with the value true passed in. Now since start delay is 3 seconds, and we're calling setPlayerEnabledState passing in false before we set our timer, when we press play, we shouldn't be able to move until this 3-second delay is up. So let's compile this and see how it works.
Compile. Okay. Run the live coda. Run the live coda. Or oh, gross. Okay. Toontanks game mode. It was online 32. Handle game start. Check. 52. Player enable. Alright, should work now. No, what? Uh, What if I just do it again? I think we'll get a different one. Failed to link. Never seen this before. Just gonna ask ChatGPT.
So I'm going to go ahead and hit play, and I
Toon Tanks player controller.h. Set player enable state. Yes, okay. Let's go then. Can't move. There we go. Kill you. Owie. What? No!
I'm trying to move around and I can't, and after 3 seconds, I can suddenly move. And also check this out. Notice that my cursor is the crosshairs. It may be hard to see on the screen, but you should be able to see it on your screen just fine. And this makes it a lot easier for me to aim and control my tank's turret rotation. Perfect. So in summary, we created a handle game start function for the game mode, and we're calling this in begin play. And we also set a timer using a timer delegate onto which we bound our set player enabled state function on the
Psycho Daddy.
allowed us to have a function callback for our timer.
What up, Psycho?
And we use this to enable user input after a 3-second delay when the game starts. Now this could be frustrating for a player if they didn't have some sort of visual cue, sort of letting them know that input is not enabled, something like a countdown on the screen. So we'll take care of that in future videos, but for
Appreciate you. All right, I'm switching into Minecraft in a second here. Gonna go refill.